Hey there! Welcome to Learning with Mass, where you can learn and upskill yourself. In this video, we will be doing unit conversion examples to practice. If you're new here, please make sure to subscribe and click the bell to enable alerts so you can keep learning with me. Okay, let's get started. If you watched the last video, you'll remember that a dimension is a property that can be measured, and that properties like mass, length, and time are dimensions. Let's convert within each dimension, starting with mass. If asked to convert from kilograms, an SI base unit, to pound mass, or just pounds, an American engineering base unit, you need to first find and write down the relationship or conversion factor between the two units. There are 0.453593 kilograms per pound mass, or per pound. Afterwards, you must write down the old unit given in the question in a fraction format and place a vertical line to represent the multiplication symbol. To put it simply, vertical line means multiply, horizontal line means divide. Always place the unit that you do not want with its associated value from the conversion factor on the opposite side of the horizontal line to make sure it cancels out. So, because we do not want kilograms, which is at the top, we put kilograms and its value at the bottom, and what we want, that's pounds, at the top. The old unit will cancel out to leave pounds. Now you can plug in the value into your calculator. Remember that the horizontal line means divide. Now that you have the method down, I'll go a little bit quicker. This question asks us to convert 130.7 pounds to metric tons. This time, you need two conversion factors to solve this problem, to move from pounds to kilograms and from kilograms to metric tons. Let's begin. Write down the old unit in a fraction format, place the multiplication line, and put the unit that you don't want in the opposite direction of what you want to cancel out. Place the newest unit at the top next to the old unit. Numbers separated by the vertical or multiplication line are multiplied. Then, the answer in kilograms is now treated as the old unit. So place that in a fraction format, put what you have at the bottom and what you want at the top. A horizontal line means you must divide the values to get your final answer. You can combine these two conversions into one and multiply the values separated by the vertical line and dividing those separated by the horizontal line to get your final answer. Okay. Let's practice doing one conversion using multiple conversion factors. We are converting from grams to pounds. We have two conversion factors, and we start off by converting grams to kilograms. This is a conversion between multiple units. Please refer to my previous video where I discussed what that is. Then, we put another vertical line before placing what we don't want at the bottom and what we want at the top. Notice that the value at the top multiplies with 1 and the values at the bottom are multiplied because they are separated by the vertical line. Okay, let's do some length conversions. It's going to be quick. We are told to convert 2 meters to feet. This only requires one conversion factor, which is 1 foot is equals to 0.3048 meters. So we write down the old unit, place the vertical line, put the meters unit in the opposite side of the old unit, and the foot unit next to the old unit at the top. We cancel out meters, divide the top value by the bottom value, and we're done. The next question requires two conversion factors, one of which throws in a multiple units conversion from meters to micrometers. You know the drill. Write down the old unit in a fraction format, vertical line to multiply, place the unwanted unit in the opposite direction, and the newest unit at the top. Add another vertical line, place the newly unwanted unit at the bottom, and the desired unit at the top. The values at the top are multiplied and divided over the value at the bottom. Okay, time to move on to time. Get it? Let's go. Given years, we are required to convert to days. I bet you know the conversion factor of this one by heart. There are 365 days in a year, so we put the years given to us, place 1 year at the bottom, and the 365 days at the top. Top values multiply and divide by 1. The next question is equally easy, with just a lot more conversion factors needed. We must convert from seconds to years. Easy, right? Let's go. Old unit first in a fraction format, vertical line, unwanted at the bottom, wanted at the top to move from seconds to minutes. Then add another vertical line and follow the same procedure to move from minutes to hours, hours to days, and finally days to years. The value at the top is multiplied with 1 and divided by the values at the bottom, which are multiplied with each other because of the vertical lines. Now that you know how to convert units within their respective dimensions, you should be able to convert derived dimensions in your sleep. Let's give it a try. The derived dimension, volume, comes from multiplying 3 values in the length dimension. When the same unit is multiplied 3 times, it must be raised to the power of 3. Be careful with this conversion. Note that raising a quantity to a power means that we must raise the units to the same power. We start off with 2 conversion factors that we need. Write the unit that we do not want at the bottom and the one we want at the top. To make sure that cubed millimeters is cancelled out, we need to raise the value and the unit to a power of 3. What we do at the bottom of a conversion factor applies to the top as well, which leaves us with cubic meters. We can then use the cubic meters conversion factor as it is to convert to liters. I hope that was clear. Comment down below if it wasn't so I can help you. In this question, we are asked to convert the flow rate of energy, a derived unit. This question incorporates the derived force units discussed in the last video. It also requires knowledge of powers. We have 4 conversion factors for this question. So, we write the old units in a fraction format and convert some of the units to Newton. Placing the unwanted force units written in SI units at the bottom means that the denominator of the unwanted units goes to the top. Then, we place what we want at the top as well. These 2 units are multiplied with each other. The kilograms, meter, and squared seconds cancel out to leave meters per second, velocity, multiplied by Newton. The top units, Newton by meters, can be converted to joules. Place the unwanted units at the bottom and joules at the top. Now we can easily move from joules to calories, the final destination for the energy unit. Joules goes to the bottom and calories at the top. Lastly, we convert the seconds to minutes as shown in the time conversion section of this tutorial. What we don't want goes in the opposite direction of what we are given, so place 60 seconds at the top and 1 minute at the bottom. Plug in the values and voila! Was that challenging enough? If not, dimension to dimension conversion should do the trick. We are asked to calculate the concentration of a sugar-water solution in molal. We need to figure out what units are required to give us a molal, so we can work towards that. Molarity is defined as the moles of solute per kilogram of solvent. The solute in our case is sugar and the solvent is water. Therefore, the units we want is moles of sugar over kilograms of water. We have to convert mass of sugar, given as 5 grams, to moles of sugar, and the density of the solution, given as 1004.4 kilograms of solution per cubic meter of solution, to kilograms of water using simultaneous equations, conversions, and logic. To convert from mass to moles, we need something that has grams and moles in there. In this case, that is the molar mass of sugar. Given the chemical formula of sugar, we can calculate this derived dimension to get 342.3 grams of sugar per moles of sugar. This is basic chemistry. I hope you're with me so far. This molar mass serves as a conversion factor. So, we put the mass of sugar in a fraction as we would any other old unit, and place a vertical line. We then place grams from the conversion factor at the bottom and moles at the top. Dividing the mass by molar mass gives us moles of sugar. The first part is now complete. For the second part, we know that the density of a solution is equal to the total mass of solution over the total volume of the solution. We want the mass of water in kilograms, we already know the mass of sugar in grams, and the volume of the cup is taken as the total volume of the solution. So, we can use the density and the total volume of the solution to find the total mass of the solution. Once we have the total mass, we can subtract the mass of sugar from the total mass to get the mass of water. Yes, it's a dark, twisted web, and yes, we can do it. We need to be able to use the solution density given to us, which has different units to the volume of the cup. So, let's convert millimeters to cubic meters. This is the normal conversion that we are used to, so it should be quick. We can multiply the total volume with the density to get the total mass of solution. Thereafter, we must convert the grams of sugar to kilograms so we can subtract it from the total mass. The last step is to take the moles of sugar calculated previously and divide them by the kilograms of water we just found. Cool, right? Well done for making it through the tutorial, and keep practicing. Thank you for watching. Please like, comment, and subscribe. Remember that sharing is caring. This video might help someone. See you next time. Bye.